Thank you for your participation. So we advise the audience that this webinar will be recorded and that its recording will be published on the website and YouTube channel of the project Remourban. Dear participants, dear speakers, dear organizers, let me welcome you all to our third and last dissemination webinar organized under the umbrella of the project Remourban. My name is Mathieu Grosjean and I will introduce and moderate this webinar. I work for a German organization called Steinbeis-Europa-Zentrum, which provides consultancy services in the field of innovation management. Remourban is a smart city project which is financed by the European Commission under the umbrella of its Horizon 2020 Research and Innovation Funding Programme. Our role within the project is to manage its IP assets and to support the market deployment of a set of solutions validated and demonstrated in the cities of Valladolid, Tepebashi and Nottingham. If you are interested in the solutions developed within Remourban, please don't hesitate to get in touch with us. We will be glad to advise you. Should you want to get a first-hand impression of what these solutions are all about, we recommend you to visit our website. The technological and non-technological solutions successfully validated and demonstrated in the project are ready to be downloaded. Just click on the info pack of your interest and get thorough inside of it. Here in front of you on the slide you can see several of these info packs. So here on the slide our agenda and a change since Arnout Andrews couldn't take part. He had a problem on an issue, an emergency issue to be solved. This is the reason why we have David Tetlow to represent or present his part. So in what follows, I will briefly introduce the main goals to be achieved by the project Remourban and how they relate to the low temperature district heating system implemented in the area of Sneinton in the city of Nottingham. Professor Yannick is a senior lecturer of sustainable energy systems at Nottingham Trent University. He will present the low temperature district heating model developed for the area of Sneinton in the city of Nottingham. The research outputs of Professor Ianakiev in the field of smart heating networks were the pillars for the elaboration of the concept behind the energy model, which structures the low temperature district heating system implemented in Sneinton. Thus, his presentation will cover both the model and the implementation of the system. David Tetlow is Energy Innovation Program Manager at Nottingham City Homes, and he is specialized in the integration of new solutions for the housing managed by Nottingham City Council. He will share with us his professional point of view on the modeling of the system and how it was implemented. His remarks are of special interest as he knows the intervention made in Sneinton from the inside. Finally, we will close this webinar with a session of question and answers where all attendees are encouraged to interact with our guest speakers. This will be the right moment for you to ask, to share your views, and to start exploring research cooperation opportunity with Professor Anton Ianakiev on low temperature district heating energy models. So let us now shortly focus on the project Remourban itself and the district retrofitting intervention carried out in Nottingham. Remourban started in January 2015 and brought together 22 project partners from 7 different countries with the aim to achieve essentially one central goal: demonstrate that the transformation of a temporary city into the smart city of the future can be ensured and optimized following a tailor-made plan of intervention in the areas of energy efficiency, urban mobility, and information and communication technologies. Remourban tackles those 3 areas through the implementation of the urban regeneration model in its demonstration sites, namely Valladolid in Spain, Nottingham in the UK, and Tepebashi in Turkey. The cities of Serra in Belgium and Miskolc in Hungary are early adopters of that model. Ultimately, the effect of cities getting smarter should have positive consequences for their own social advancement, environmental regeneration, and economic growth. Moving the focus to Nottingham, its City Council has identified the building sector as decisive to achieve sensible energy savings throughout the implementation of different schemes, one of them being the introduction of a 4th generation district heating system in the district that allows this technology to be deployed. The equipment of such heating system, with ICT elements, makes the system smart and fosters Nottingham's ambition to become a smart city. Our guest speakers will develop these ideas further. So at this point, the only thing left to mention is that your microphones have been muted to prevent any interruptions while the speakers carry out their presentations. Should you have comments or questions for our speakers, please don't hesitate to send them using the chat box. I will collect them and ask them aloud to our speakers at the end of this webinar. Having introduced you to the project and the objective of Nottingham City Council, the next presentation will be on charge of Professor Anton Ianakiev, who will dig deeper into the low temperature district heating model and the implementation of the low temperature district heating system in the intervened area. Professor Ianakiev, the floor is yours.
Hello, Matthew. Hello, everybody. I just need to move to the slides up. Yeah, sorry. Okay. Why, first of all, low temperature district heating? Why Nottingham? Low temperature district heating is the most efficient type of district heating available at the moment. It's also called the 4th generation, with feeding temperature of 60, 65 degrees, even lower, 50, 55 possible. Due to various advantages, which I mentioned later. But why Nottingham? Nottingham has one of the biggest, maybe the biggest district heating network in UK, with more than 5,000 homes connected, with 100 businesses also. What we have proposed in this project is to replace the standard gas boiler heating in 94 flats, in 4 block of flats in Sneinton, Nottingham, with low temperature district heating, and we're using the source of the heat, a branch emanating from the return pipe of the primary mains of the district heating, existing district heating system. So the return pipe has temperature between 60 and 65. So by taking a branch emanating from the return pipe, we are supplying effectively these 94 flats with heat of between 60 and 65 degrees. What are the advantages of the low temperature district heating? First of all, by reducing the temperature level, we actually provide opportunity to incorporate sustainable heat. So the heat can be diversified by industrial excess heat, geothermal heat, etc. Also, by reducing the temperature of the supply, we are reducing the heat loss by 75% due to transmission. Since we're using also lower temperature, we can actually diversify in terms of material of the pipes. We can use, for example, not only metal pipes, but plastic pipes. And also finally, due to the reduced temperature, danger of boiling and getting a damage if there is some damage in the pipework can be also reduced. The next slide illustrates how the actual retrofitting being done. My colleague David Tetlow will talk in much more about the implementation, but essentially what we did, we tried to improve the building fiber by putting isolation on the walls, and also you can see the actual pipes for the roof of the connecting staircases. Now, since the system been running from March, April this year, we have used SCADA system to collect data, and by writing programs based on Python programming software, we can collect and visualize in much more advanced way the actual consumption and how the heat is being consumed in various places. So what you see on this plot is the supply, return, and flow rate for a particular flat in a building. And you can see for a full month in April, starting from 1st of April until end of April, how every day the consumption is varying. On the right side, you can see the actual consumption in 22 flats in one of the buildings, and you can see that various customers use various ways of consuming heat from the network. Some actually consume more heat, some less heat, some actually absent. So you can see flat number 13 has used only part of the month, not the whole month, the heating season. Based on the supply data, we are trying to develop some advanced models. So the first model that we have developed, based again using the Python programming language, is to do hydraulic balance of the network. So for the Byron cord, which is displayed here, there are 31 flats, and for each flat we have developed a space heating system at the top of the slide, and we are trying to work out how best we can supply the network so that we minimize the energy used. The next slide, you see that we have programmed 4 different scenarios. The first and the second scenario actually provide constant temperature supply at 60 degrees, but the first and third first is using constant flow rate, while the third is using variable flow rate. Scenario 2 and 4, we supply different water temperature with a constant and variable flow rate. Using the Python model, we have worked out that scenario 3 actually provides the lowest energy consumption in kilowatts, and is probably the best scenario to run the network. Based also the SCADA data that we collect, we're trying to develop advanced simulation model. This model is particularly developed based on the Modelica Daimler platform, which we're aiming to model and simulate complex energy system. With using the Modelica platform, we are nearly able to develop the so-called digital twin, which actually can produce real output data, and based on using Energy Plus, another program to generate the heating needs. In these plots, you can see that the individual cores are developed into individual subsystems, and on this subsystem we have another layer of subsystem to develop the modeling of the individual flats. The present model is still in development, but it has produced some initial results which are very, very encouraging, and we are planning actually to develop it further. This model is based on the initial development, which can be improved later. Apart from this, we are also developing the so-called intelligent control system using Siemens MindSphere Internet of Things. What is the important element of Internet of Things is that we are creating the so-called domain knowledge, which include some historical data concerning energy used by individual consumers, some weather data, etc. And we can actually analyze how the system operates at all levels for a complete life cycle, for example. This system is also under development, and what we are aiming to achieve is to optimize the energy use in the storage, allow provision of alerts and alarm for assisted living, so the system could be implementing a real application, controlling the operation of the low temperature district heating. Also, the system permits some energy consumption feedback for all the tenants, etc. Some advice how they can run in the best way their own heating system in the flat. So, in a summary, I would say that an innovative low temperature district heating network is developed in Nottingham, supported by the Remourban project, part of the smart city community. 4 maisonette block of 94 flats are being selected, where gas boilers being replaced with heat exchangers, and they've been joined to the local district heating in the form of low temperature district heating. Advanced modeling technique are developed aiming to be level digital twin for the low temperature district network, and these models are developed using real data from the network. These models allow rapidly to look into influence of the main parameters network and introduce modification when needed to optimize the overall performance. The main aims are to reduce peak loads and to reduce the return temperature of the network and make it more optimal and more efficient. This is from me, Matthew. Back to you.
Thank you, Anton. So, I think that let's now hear the vision of an insider. David, you are most welcome to start with your presentation.
Thank you.
Wait a minute.
So, okay, are we ready? Okay, I'm going to assume that is a start. So, hello everybody. I'm obviously taking part of Arnout today. He's been taken into another meeting which which has occurred last minute due to some another project we have on. So I get the opportunity of presenting this to you today. But me and Arnout work very closely, so a number of the parts of the presentation that we're to discuss I'm very familiar with. So, this one. Okay, so it's that one there. Yeah? Okay, so short introductory slide here, which kind of outlines the reasons why we are originally pursuing the project, which essentially comes down to 3 set things. One was to meet our climate change targets by 2050 for all of our homes within Nottingham. Now, Nottingham has a substantial portfolio of councilly owned properties which have a range of tenants in, and 26,000 in over 26,000 in total, and its aim is to become carbon neutral by 2028. So a significant ambition for the main city itself. Essentially, we're looking to reach our 2050 targets by 2028. So this technology is an enabler in that process for us. Now, this is great, but obviously that just provides us 9 years to implement this. So, but this is kind of these options we've been thinking about since 2016. So where are we going and where we are? Well, as mentioned, we have quite a substantial housing stock, this being a range of types. So the one you can see there within the picture is Bentic Court. So this is one of our high-rise stocks. But we have a range of low-rise and individual units. So the thought horizon is basically how do we get there for our entire housing stock? How do we make this stock carbon neutral? So one of the potential opportunities we have as a city, which Arnout inferred to reach our 2028 target, was the extension of our existing heat network. Now, we've expected this. This is nearly 50 years old. In fact, it's more than 50 years old this year, I believe. And with that, it's high temperature. What we do is we burn our waste in the city, and this provides heat to all of the properties, which Arnout mentioned previously. And it has a significant capacity and power, but because it feeds a certain number of house types, which are particularly a large proportion of these being inefficient, the improvement of the efficiency of those houses enabled us to do an extension of the existing network, because more energy could be spread to more properties from that network. So that enabled us to expand where we could go with the existing network itself. This is a typical building which we focused on in this project, a low-rise set of 4 buildings with 94 flats in total. Now, these were in Sneinton, and we call these the courts, and the number of units in each property is a various range. Some have more than 30, whereas others less than 30. The first thing we aimed to do, obviously, was to improve the fabric, mainly so the heat could go further, as mentioned in the previous slide. So we improved the fabric, we improved the air tightness, and we made them more comfortable for the tenants inside there. Now, this would reduce the loads on heating in general, but also we were looking to change the methods and how people utilize their heat in there by incorporating the low temperature district heat network, which would mean a change in how heat is distributed in terms of temperature, but also looking at how people are utilizing energy for cooking as well. So many of the existing tenants use gas cooking, so this project enabled us to look at other options for like electrical cooking too. So it offered us a range of energy reduction opportunities. This is the building today, as we've shown what we've done in the improvements in the fabric. Essentially wrapped it in insulation, improved the air tightness, also done a number of architectural changes to the way the construction of the buildings are laid out. Where previously balconies were incorporated, we kind of incorporated those into the living space, which was it significantly improved the floor space of the stock and improved the well-being of the tenants as an idea. We incorporated photovoltaic panels on the roof, which are then fed to a private wire network via batteries, which then enabled us options to gain access to lower tariff electrical supply from our energy supplier, and become more cost effective for us as a business in terms of managing our energy, and make it enabled us to provide better services for the tenants, and also the expansion of the district heat network through the low temperature district heat network, which we've covered in this session. So this here, although be a boring looking shed type building, was the extension block for the network. So this is, as I think Anton mentioned previously, houses a heat exchanger which is connected to the district heat network, which is high temperature, and we take it in at low temperature. Here is an example of where the flow goes in. So this heat exchanger then is passed on through the system and is controlled through a number of state-of-the-art systems. Here is an aerial shot of the 4 buildings itself. So as you can see, the main ones here are, as we call these, the primary buildings, are much larger than the secondary ones, as you can see here, but all of them were connected through a return flow, which fed all these, which have PV panels on the top, which feed into battery cells, which are housed within the cellar areas of the main buildings via these units that you can see here and these all being controlled to enable efficient use of the electricity in those buildings. Here is an example of the meters that we utilize. Now these are wireless, so they connect to our online system and enable us to monitor the energy, which I'll cover in detail more later. So for the tenant, what were the advantages? Well, essentially, as you can see here, there are a number of things. The first being bigger homes, they look better, they're more comfortable, and an overall neighbourhood improvement. The neighbourhood improvement was one of the key factors for us, because there is an element of stigma attached to social housing within the UK. We wanted to improve that. We wanted to make them attractive so people could feel proud of living within the particular neighbourhoods. We also wanted to make it get a lot of people out of fuel poverty. So we were aiming to reduce bills from down to £600. Now this was a significant reduction, because many tenants were paying upwards of £1,000, some £2,000 per year just to stay warm. We improved the way people could pay, so we incorporated web platforms, automatic payments from the bank. We enabled a number of different options for them, so it didn't significantly impact the way in which they managed their own energy. And we also enabled them to have data access to the web platform if they so choose to do that, because what we're finding is more people are becoming internet savvy these days. And the other thing, it provided a safety net, because all the way through we provided informed intervention where we were updating tenants and keeping regular contact with them. So this is as an example of our online platform, which we utilize to assess the amount of energy within these particular location. So the main one which we were covering in this example is the courts element here, but this is just being one node where we can essentially access this. But this is another project we have close by, which was part of the same project, which is the Energy Strong properties, which is a different concept altogether, but it also incorporates the concept of the low temperature district heat network on a smaller scale than what we did in the course. I'm calling you, should I? This is an example of the online platform which provides information which can be adapted quite fairly easy. And we engineered this to provide us with key information, so we could check online in time with data to see whether there were unusual occurrences going on, and if there were problems, we could assess where the issues were, and we can send out engineers if necessary to resolve issues quite immediate. Okay, this seems to, okay. This is an example of the second part of it, if we were to click in certain areas, and you can see information on the exact system itself. So it's fairly adaptive and programmable to enable best management of this system by people. So as I've mentioned previously, before the refit, we had mainly gas heating and central heating. And on the day, all central heating, most had all day and central heating on at night. Most properties were fairly cold, and now the heating is only on 1.5 hours a day, and it stays warm all day long for tenants. So it's a significant improvement in their well-being and their lifestyle. What we're finding on feedback from tenants is they're much happier. Essentially, it's fairly you know, a significant improvement to their overall well-being throughout, and in particular in the winter. One comment which really hit us was the fact that someone said they didn't have to wear a coat at home anymore, which kind of shows the level of impact this has for people. Okay, I think that covers all of my contributions, so I'll hand you back to Matthew.
Thank you very much, David. I would like to remind the audience to write down the questions that you might have in the chat box, because the question and answer session is now open. I think I would have a question for you, David, related to how was the interaction that you had with the model presented by Anton Ianakiev, and the setup of the solution in the courts with the low temperature district heating. Was it useful? What are the main advantages that you find in this model and the way to use it?
So as a business, information is key for the successful function of these systems and also for the successful integration. One thing we find that we've had on previous projects where we've integrated low temperature heat systems is the disassociation between the contractors that install the systems and us as a client. Now, this project, having the academic partner involved in the form of Anton, enabled us to be more involved in the design of the system and gave us more of an education on things we need to look for in terms of better improving our systems and making them more cost effective. In answer to that question, the parts which are fairly useful to us in terms of the online user platform, well, we were kind of involved with the provider at key stages along the way, and the design of that interface was based on what we would require information wise to supply information to, so we can make a decision on who we need to send out in terms of engineers, etc. So the in-time acquisition of data is extremely key for us. On other systems, as an example, we have to send out engineers to read meters, and it's very disassociated. It takes time. The efficiency this type of interface can bring is a game changer for us.
Thank you, David. Okay, now I think I have a question for Anton. Having a low temperature district heating working with return heat of existing network is really perfect, since there is no need to produce more heat. Just take the excess heat and re-share it with potential buildings. Would it be possible to implement low temperature district heating in other situations?
Yes, for example, the other project that David actually mentioned, the Energy Sprong, which initially Remourban funded for 10 houses, but now is extended with government fund to another 155 houses. And there are also, David is saying that there are more money coming actually to expand even further. This actually, we're using, we're creating a local low temperature network where feeding temperature is 45 degrees. And the source of the heat is heat pump, geothermal, not geothermal, sorry, ground source heat pump. So several boreholes actually being drilled with depth of 135 meters, and they provide a constant temperature of water of 11 degrees, which is heated by the heat pump to 45 degrees and heat the houses. And to run this heat pumps, electricity generated by the PV panels on the roof of the houses is also used. So to some extent, this is an integrated or hybrid system where we have electrical and heating system connected together. And it's also an example of low temperature district heating. The advantage of such a configuration is that we can reach efficiency to 70–75%. So it's a substantial reduction of the energy consumed. Of course, the level of investment is much higher than the low temperature because there are other factors involved.
Thank you, Anton. I had another question because I heard about the fact that in the UK, and I think it's not the only country in Europe that has this point, but there are some standards for the heating of flats, which invite or tell that we need to have quite high temperature coming inside the radiators in order to heat flats. And I think that with the low temperature district heating, since the temperature is much lower than the one expected or in the standard of the United Kingdom, there were a lot of doubts from the companies seeing Remourban using or setting up low temperature district heating. Can you speak a little bit about that, Anton,
yeah.
or David?
Yeah, I'll say something about this, and then also David probably can add something. Yes, by reducing the temperature of the fluid that is hitting the flats, you're effectively reducing the output, the heat that is transmitted. But generally, I can say that the radiators in the flats, they are oversized. So even by reducing the temperature of the fluid, they still actually can perform the job they're designed. But for some cases when the building is actually not very efficient for various reasons, historical, etc., poor design, poor workmanship, etc., it's recommended to do retrofitting before introducing low temperature district heating, so to improve the building fabric and to reduce the energy loss, to improve the air tightness, etc. So these are two components that can be considered. If the building is relatively good in terms of energy performance, then straightforward, you can introduce the low temperature district heating if the performance of the unit need to be improved somehow. I'll pass to David just to add something to this.
Yeah, just adding to what Arnout has said. So the low temperature element of the innovation is a key factor for us as a business in terms of the successful function of the buildings. One issue being in previous cases that we've had with the capital investment we have to put into integration of these systems is predicated on users within the building utilizing heat in which we provide to them, and system losses in the building, particularly within new build cases, are leading to people not utilizing heat. So, for example, in our senior generation housing blocks, the heat which is lost in the system is heating the building, and people are not having to utilize heat in their own flats, as an example, and that can lead to loss for us as a business. So the low temperature element of it is an important factor because it mitigates those system losses. Another element which is kind of a side impact of installing low temperature systems is the comprehension change for tenants. So what we're finding is that as Anton has said, it's more cost effective for us to leave radiator systems, existing radiator systems in properties. One being the fact that we'll have installed them only a few years previous, and these things have lifetimes of 10 to 15 to 20 years in some cases. So it's not cost effective for us to replace them. So we're leaving them in the system, but because of the energy requirements have been reduced, the temperature of those systems doesn't increase. And what we're finding is tenants are saying to us, my radiator, the system isn't working, the radiator is not getting warm, or is not hot. And our response to that is, well, are you comfortable? And they're saying, well, yes. There you go. So it requires a significant comprehension change and also a re-education of our tenants. So because it creates a problem out of nothing, because they're expecting the older system, whereas they've been giving a new system. Similar to, it's akin from going from an old mobile phone to a smartphone. That's the analogy I give them.
Thank you very much, David. So before closing this webinar, a big thanks goes for the people who helped make this webinar possible. The same goes for the audience, for your interest and attention. This is the last one of a series of dissemination webinar, which aim has been to bring innovative Remourban partners together with a broad range of stakeholders. Steinbeis-Europa-Zentrum has been honored to facilitate such interactions as both organizers and moderators of this webinar series. We are proud of having done our best to generate this dialogue where our project partners had the chance to reach potential users for their respective innovations among the scientific community, industry players, and policymakers. So yeah, I think that's it. We hope to meet you again soon, and take care.